Hi everyone. Thanks for staying for the talk. Today, just want to talk a little bit about moving beyond reporting on coral cover and trying to bring together a little more the different aspects of the ecology of the reef that we monitor, but it's very challenging to communicate and to use all together to be able to advise where we're headed in terms of management actions. I hope I can press the right buttons. First, I just want to acknowledge the traditional owners where we meet, but also for those countries where we all work at AIMS and also part of the BRAP program. I want to pay my respects to the elders, past, present, and emerging for tomorrow. And I also want to acknowledge that this is a big team effort. It took us about 2 years to really think a little bit about it. But what I want to present to you is something quite simple, like because of time constraints. But there's a lot behind that this amazing group of people contributed to make it happen. It was also a work guided by the Reef Authority to actually trying to implement the framework that we're trying to design into reporting, but also guiding some of the decision makings at a large scale. And obviously, it was funded by the Reef Trust Partnership and AIMS as well. The rationale of why we started this work is because we do a lot of monitoring across the reef that covers various different dimensions of the ecology of the systems, but also there's a lot of research that adds value to that. Like in EcoRab, there's a lot of assessments of the demographics and understanding of the relationships to habitat and environmental conditions. But it's also a lot of published research done along the way to actually help us understanding how the reef functions and how the reef transitions over time. But on the other side of it, we want to actually simplify that in a way that we can make decisions a lot quicker and more informed. But having all these different dimensions is always very challenging to convey and to prioritize what are the areas that needs attention and why. So we kind of came out with this black box that we're trying to kind of push everything together into some way to actually summarize and convey the message about what the condition of the reef is. So Reef 2050 has a target that says that we need to maintain a good condition of the reef, but what is a good condition? How do we define that in a quantitative way? That's the reason why we started doing this work. So there's been previous work done in defining some of the key indicators that we think that are relevant, and that a lot of those metrics has been monitored for over 30 years in the Great Barrier Reef. But we actually start teaching apart a little bit more what do they indicate and what do they tell us about. So we have coral cover as a bit more sort of generic proxy for ecological services, for maintaining key processes. We also have macroalgae cover as a sort of as an indicator of competitive pressures and space availability for recovery. Community composition, more and more obvious, we're kind of realizing that reef are actually changing, and we need to kind of acknowledge the fact that the composition indicates a little bit the stability of the system if it's changing. Recovery performance as a way of a metric to indicate whether the reef is going in the right direction or not, and juvenile density as a way of measuring the capability of the reef to actually kickstart that recovery. But the other part of this work was trying to understand how we set expectations to those indicators. Because the reef is so vast and so diverse, how do we acknowledge that the reef is so different, but at the same time setting some values that can help us guide in policy making and decision making, and to say, hey, your reef is in good condition or not good condition. So we have here in this diagram or this graph, the different indicators, and sort of if you imagine one of those, then you can see that sort of they varies over time quite a lot. And sort of to start setting up those expectations, we first looked at, can we set up some reference that indicates the maintenance of those functions that those indicators indicate, but also give us a reference to say, well, are we actually above or below that value? And I'll explain that in a little bit. But we also realized that below the maintenance threshold, that's the part where we really want to tackle that sort of the decision-making part. And if we actually leave it too late, then we might actually be in a bit of a pickle situation where sort of it's a little bit too late for us to make decisions. So we wanted to actually find a contextual threshold that I explain what it means, but actually give us a bit more of a reference to know when the reef are actually in a much more critical situation. And some of that is actually trying to recognize that reef bounce back and forward. So we want to actually understand not only that the reef is in a relatively bad shape at some point, but whether they have the capacity to recover or not in the following years. So if I give you an example with coral cover, you can easily see sort of values of coral cover going up and down, and sort of what I'm going to talk about is those thresholds that indicates the maintenance or the contextual values of those indicators over time. And if you can think about it, then you can actually put a scale to that. So if you're above the maintenance thresholds, you're in a much better situation, but the critical or contextual threshold is what actually gives us that indications of the very poor state or critical values. But acknowledging that sort of the reef, as I say, is very variable, we needed to actually set up some spatial references to know that that we are talking about the same thing. So we used the bioregions as environmental provinces to actually outline or separate those reefs that we think that are more homogeneous compared to the rest of the other reef in the Great Barrier Reef. So this is the work that's been done back in the days in 2001 that delineates the bioregions based on the environmental provinces of the GBR. So having a spatial reference gives us a little bit of a bit more of a summary, but we also needed to acknowledge that the reef varies over time and a lot. So we needed to actually set a reference to understand what is our we call it baselines to define those thresholds. And I just put in inverted commas because our monitoring has only been happening for 30 years, so our baselines is relatively recent. But in that period, we have realized in this work by Mike Emslie that the amount of disturbance that a reef has suffered, or the number of reefs that have been suffering disturbance over the years have increased dramatically in the last 2 decades. And if you see those, the graph on the left, that's the proportion of reef over time that have been affected by several disturbances. But on the right is also the timing in between disturbances has also been shortened. So it means that the reef have much, much less capacity to recover. So we identified the time from the beginning of our monitoring in the 1990s to about the 2010, where things got a lot much worse. And that's the time that we use as our reference for the thresholds. Then when we talk about the contextual threshold, so those values that indicate those critical states, that's the coolest part of this project, I think, because that's when we started looking a little bit more about the theory of what we understand about the systems. So it's no longer driven by our data, but more so driven by the ecology and trying to use that to add some additional values to those observations that we see in the reef. So, for instance, when you look at coral cover, we investigated what's the values of coral covers at which carbon budget becomes more negative. This is a work done by Mumby and was done across various different bioregions as well to then generalize on what's the values at which coral cover are actually too low to limit the carbon budgets in the region. There's also some work being done in terms of relationship between juveniles and macroalgae that helps us understand at what point the amount of macroalgae can actually limit the juveniles and that therefore causing bottlenecks in the systems. With the community composition, we looked at novel states of the communities and trying to using this analysis that's called local outlier factor as a neighborhood analysis to identify at what point the novel states of the community becomes more settled in the systems and therefore more likely to actually change over time or remain there over time and therefore changing the way how the reef looks like and operates into the future. In terms of the recovery rates, we use a recovery model that uses coral cover over time and then predicting what's the likelihood of a reef to actually stay underperforming or not in a particular year in terms of the recovery trajectories. And then for the juveniles, we use a lot of data from EcoRab, but also work done by Chris Zoropoulos and others to try to feed in some of those demographic rates that Chris was talking about into integral population models to predict at what point what's the minimum number of juveniles that you need to have in a reef to prevent recovery of the reef. So at what point the juveniles becomes too low that then the reef doesn't recover anymore. So we were sort of looking at that work with JCU as well. So very quickly on this, then the last part is about the interpretation of it. So when we put it together, then we can quickly identify sort of the best and the worst scenarios. But the most interesting part is those warning cases where sort of there's not necessarily entirely everything is pear-shaped, but there are some combination of parameters that are doing well and bad. And sort of without necessarily getting into this horrendogram too much, but I just wanted to show you that then we needed to actually get somewhere that we can summarize this even further to actually identify what are the reefs that are the highest risk of perhaps continuing at the gradient trajectory. So we looked at a more sequential process in terms of like state variables like coral cover at the top, recovery trends in the middle, and then processes like recovery, recovery and juveniles and macroalgae to try to then tease apart at what points they're actually in a much more risky scenarios. So if you look to that, for instance, to the left of that, you follow that, you have like high coral cover, your reef is recovering really well, and then your processes are actually working quite well, so you are in a relatively low risk and good condition. But if you go to the right, you are in the worst situations. When you are in the middle is when you start teasing apart a little bit more why the reef is actually not necessarily in a relatively good conditions and what are the risks that the reef is actually less likely to recover. Because I'm a bit of a geek, I also sort of then trying to put that together into more of a dashboard where then you can use auto-generated text to provide context to those that are making interpretations out of that. So this is a draft of work that we're trying to formalize a little bit more, but it's a shiny app that helps us to then navigate through the reef, allowing to looked at different scenarios, test our assumptions of these indicators, but also being able to add a lot more context, like how many like what are the species that are increasing or decreasing in the reef, like what's the context around the density of juveniles and so on, to help communicating the complexity of the reef in a more kind of structured way, if I put it that way. So I'll leave you with that. If you're interested, there's a QR code, you can have a look at that. But if you're interested in reading a little bit more about it, we also have all that documented, so there's a QR code there for that. Thanks a lot for that.
Thanks, Manu. Chris.
Great talk, Manu. That's awesome work. Super exciting. I'm just a detailed question, I guess. You're talking about novel community states. What kind of level of community are you working at? Functional, species composition? Can you just elaborate a little bit on that?
Sure. That's a good question. We've been using the lowest taxonomic level that we can get from photograph from the long-term monitoring program. Most of that is at the genus level and is updated to the newest taxonomy now. But in some cases, we can get to morphotaxa. That's kind of where we are. And unfortunately, the soft corals are a little bit underrepresented in terms of taxonomic resolution. Sorry, Katerina.
This is not a question, just a clarification, just in case. The auto-generated text doesn't use artificial intelligence to generate the text. It's actually based on rules that we write, because everything auto-generated at the moment is ChatGPT. Yeah. That's not what that is, just clarifying that.
Yeah, good point, thank you. We might get there.
One more quick question? No? Okay, thank you.
Thank you.
Thanks so much.